Well, hi there, and welcome to another live show here at Slooh. I'm Jerry Montour, your host and your expedition leader, as always. And tonight we are looking live through our telescopes in the Canary Islands at an always gorgeous and impressive sight. It's the gas giant Jupiter. And now, Jupiter is the largest planet in our solar system, incredibly colorful, and one of our favorites to look at live. Tonight we are celebrating a very special event as Jupiter moves toward its opposition, the day when it's brightest in the night sky. And here to explain more about what we're looking at is our very own Slooh astronomer Paul Cox, who is in the Canary Islands tonight. Paul, good to see you. Tell me what we have tonight.
Well, we've actually got my favorite night of the entire year. I'm an absolute Jupiter fan. There's always something going on, and that's what we're going to see tonight. If Chile comes online later on, we're going to see a whole day of Jupiter. So we're going to see every single aspect of Jupiter there is. So it's the opposition. Jupiter is at opposition to the sun, and we got loads of fabulous live feeds like this one. This is our all-sky camera. That thing looking like the sun is in fact the moon. So the moon is bright above me. But if we look to the left of that, Jerry, there's a bright object there. That's Jupiter. So it's still very low down on the horizon. So the images are going to improve as the night goes on. And I think we've also got, the dome cam coming up, which we should just about, and there it is actually. That's, no, that's actually the moon that's in the top of the dome cam. So we'll take a look maybe at the T2 wide field, because we're going to talk more about the T2 wide field later on, Jerry, because it's how we're going to see the Galilean moons, those four of the largest moons of Jupiter that he discovered. And there they are, in fact, so we can see three of them. But we'll talk about that a little bit later. The one off to the left, actually, I didn't realize that was going to be in the field of view tonight. That's a very bright star in the constellation of Virgo. So, and there we see three of the moons.
That's fantastic. And Paul, this is a wonderful opportunity for people out there to get a close-up look at the biggest planet that we have to offer, as well as its moons. With a clear sky, it is quite possible tonight.
Absolutely, and we've got a live video camera hooked up to the new Canary 4 telescope. And this is a little bit muddy at the moment because Jupiter is low down, but there it is. There is the gas giant at its biggest and its best. And we can just see a little shadow just to the top right-hand corner of it, Jerry. And that's the moon Ganymede and its shadow, which is going to be transiting until roughly the end of the show. And then we will just see Ganymede, the largest moon in the solar system, pop out from being in front of the face of Jupiter. So we've got it all to look forward to tonight.
All right. Now, you mentioned Ganymede. That's one Jupiter moon. I read something today that actually blew me away. And I know you know this already, but there are 67, count them, 67 moons on Jupiter.
And those are the known
around
ones.
Jupiter.
Exactly. And of course, you know, these four that we're going to look at a little bit closer on later on tonight, these are the largest objects outside of the sun and the planets. These are huge. If these were elsewhere in the solar system, orbiting the sun and not Jupiter, they'd be regarded as certainly a dwarf planet, but probably a planet as well. Oh, constellation cam there, Jerry. Now, if anybody's got a DSLR camera at home, they can get this kind of shot. But the thing that I would really suggest people do tonight is grab any pair of binoculars. Doesn't matter how powerless they are. They can be a toy pair of binoculars. Point them towards Jupiter, which rises in the east just after sunset, and they will see these four Galilean moons strung out along the side of Jupiter. Galileo called it a string of pearls.
And we'll talk more about Galileo later on in the show. And very quickly, the word opposition means what again in this context?
Well, Eric's going to talk about it a little bit later, but a lot of people kind of refer to it in the wrong way. Jupiter tonight is in opposition to the sun, right? So it's kind of not Jupiter's opposition. It's not it's in relationship to Earth. So that's why Jupiter is rising in the east as the sun is setting in the west.
All right, very good. Jupiter at opposition. Paul, thanks a million. Great job. Paul will be back shortly to show us how we can actually go back in time and rediscover those moons, just like Galileo did more than 400 years ago. It's all about Galileo tonight as we look back on one of the most significant discoveries in history. Slooh astronomer Eric Edelman will join us to explore the opposition itself and discuss why we continue to be fascinated by Jupiter even to this day. And Slooh's human spirit correspondent, Helen Avery, will be here to talk about the tectonic shift Galileo caused with his discovery of Jupiter's moons and what happened to him and his reputation as a result of that discovery. And of course, we'll continue watching our live feeds of Jupiter as we witness the movements of the planet and its famous moons. And as Paul said, that video, that shot is going to get better and better as Jupiter rises in the sky. So Eric Edelman up next. Don't go away. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com. And welcome back, everybody. I'm your host, Jerry Montour. We are looking live at the gas giant Jupiter. Jupiter at opposition tonight, meaning it's closest to planet Earth, the closest it'll be this year. The question is, why are we still so fascinated by Jupiter? We know everything about it, but it occupies our thoughts, especially when it's this close. Here to help us figure it all out is Slooh astronomer Eric Edelman. And Eric, first of all, I called Jupiter a gas high. I called Jupiter a gas giant. What does that mean?
Well, it's really gassy. It ate a lot of food and is having trouble this weekend.
Oh,
So
don't go
what
there. Don't go there.
what's going on is that Jupiter accumulated this huge envelope of hydrogen and helium. It is by and large, the biggest thing in our solar system besides the sun. It's about 318 times the mass of Earth. So there's not just a lot of gas, there is a whole lot of gas. It's huge and it influences a lot of the ways that things in our solar system work. It has a lot of gravitational pull to it. So, yes, gas giant. A lot of gas, very giant.
Eric, from what I've read, we also owe Jupiter a debt of gratitude for saving us in a certain way. Is that correct?
It depends on who you ask, honestly. There's a little bit of debate about that. But so Jupiter has this gravitational pull, and so that means it does influence some of the smaller bodies and even some of the larger ones in our solar system. And so people talk about Jupiter being sort of a vacuum of the solar system, something that is target practice for some of the objects that we wouldn't want hitting us necessarily, and things like that, and also influencing their orbits, shooting them out of the solar system. And we do have a lot of examples of that, in particular with long period comets. So we have comets in our solar system that are closer by. We see them coming by a lot. The shorter period comets are ones that hop by the inner solar system every 200 years. Yeah, super short amount of time, I know. And then the ones that are longer period, those are 200 plus. They can be around 300, they could be around 10,000 years before they take one trip. These ones can be more out in the Oort cloud, that really, really distant sphere of debris that's orbiting our sun around like 1 to 2 light years away from us. So really, really far stuff. With Jupiter, there's some evidence of some of those long period comets getting their orbits sort of perturbed and sent out of the solar system away from us, getting things as far away from us as possible, which is good. There's not as much of a chance of collisions with things. But then at the same time, Jupiter can shoot things away, but it can also shoot things toward, which is the unfortunate part. So one example of that was, I believe it was the Lexell's comet. It was a couple centuries back in 1770. That was the comet that passed by closest to Earth in recorded history, about 1,400,000 miles away. And the reason it did so is because Jupiter perturbed its orbit over in our direction. Then after that, it perturbed the orbit way out, way far away. We think it might have even shot out of the solar system, that it's not ever going to come back. It's currently a lost comet. So this is one example of one comet where Jupiter has shot something toward us and also away from us at different points in time. So as to whether or not it's a protector or a aggressor, I mean, it really depends on the point in time. Jupiter is capricious. Sometimes it helps, sometimes it doesn't help so much. So yes, protector in some ways, not in others.
All right, friend or foe, it's up to your interpretation. All right, Eric, it's also been called by some a failed star. What is that?
Well, I mean, isn't everything except a star a failed star in some way? Just maybe a little
Okay.
bit. But so Jupiter is not as big as a star, and I think that's where that gets to. Is Jupiter is pretty big for a planet, but it's not quite big enough for a star. So how big would it have to get? How much more material would it have to accumulate to become a star? That's the question. So there are brown dwarfs out there. Brown dwarfs are sort of the bridge between planets and stars, sort of the intermediary. And a brown dwarf is something between 13 to 80 times the mass of Jupiter. That's when it can't. So a star, what it can do is it can get really hot because of all this material at high pressure and high temperature in its core. It's all pushing down in there and can start to fuse hydrogen in there that produces energy, produces light that we see. And so Jupiter doesn't quite have that ability. Brown dwarfs don't either. They can sort of fuse a little deuterium, and it's a little bit of a lighter transition. But then once you get to 80 times the mass of Jupiter, that's when you start to get that hydrogen fusion going on. So slam 79 more Jupiters into Jupiter, and Jupiter won't quite fail as much as being a star, perhaps. So it's not quite there. It's a long way from being a star, but I guess it depends on what you're saying it relative to, like relative to Earth, it's a lot less of a failed star, but relative to a brown dwarf, it's a bit more of a failed star. It's all sort of this continuum process there.
I kind of feel sorry for it now. It wanted to be a star, but didn't quite make the grade. So, Eric, how often do these oppositions take place?
So oppositions, they're happening, well, planetary ones are happening with the planets that are outside of us, more distant from us, or distant from the sun than we are. So those are the outer planets. The inner ones, we don't have those oppositions because those planets can't sandwich us and the sun. They can't get on the other side of the sun than we are. They're always inside. So the outer planets, those are the ones that we can talk about. And so what makes an opposition is when we're all lined up, the sun, us, and that outer planet. That happens at different times based on how fast that other object orbits. Like take the case of Jupiter, for example. Jupiter is orbiting Earth, or orbiting the sun, and then we have Earth that's orbiting the sun faster, and it has a shorter amount of distance to travel. So Earth has to orbit the sun once and then orbit a little bit farther to catch up with how much Jupiter has gone in terms of distance since Earth started that orbit. So it takes Earth about 399 days to get from one opposition to catch back up with Jupiter. And so that's what we're seeing right here. Wonderful little visual of that. And so that's what's actually called a synodic period. And so we have those periods with each of our outer planets. Like Saturn, it's 378. With Uranus, it's 370. With Neptune, it's 367. You see, the farther out we go and the longer the orbital period of the planet we're talking about, the closer to just an Earth year you get to having an opposition. Mars is the worst in terms of how many times we get it. We get one with Mars every 780 days because it's orbiting a lot faster relative to those way outer planets. So for our gassy icy giants way out there, we get one with them about once every year, a little bit longer than that. So they keep going around as Earth orbits around and catches up with them each time. So Earth's pretty speedy relative to those, which is why we get so many of them.
Okay, got it. So roughly 13 months from now will be the next one with Jupiter.
Precisely.
Eric, the favorite thing I learned about Jupiter in the past few days is it has 67 moons. 67. Last time I checked, we had one here. Jupiter has 67.
And those are just the ones we know about.
Right, exactly. What is your favorite thing? What's your favorite thing about Jupiter?
So the really exciting thing, and I think goes toward what we're experiencing right now, we're watching Ganymede transit across Jupiter. We're seeing that shadow across the surface of Jupiter, is that we're seeing from the outside what we will experience inside the summer. So we are looking, that shadow of Ganymede across Jupiter, where that shadow is the place where you could be standing on Jupiter and experiencing a total solar eclipse. So that is pretty cool. And I mean, I'm happy we're not standing on Jupiter and in the middle of dying right now, but it's showing you what you will experience from the outside. So on Earth, if somebody on Jupiter was looking toward Earth when the total solar eclipse in August was happening, we would be seeing the shadow of the moon traveling across Earth, just like we're seeing this right here. So it's just another perspective on an event that we get here at Earth. So it sort of brings us closer to these planets, this planet and its moons, I think, because of how similar the experiences we are get in a different way, but there's similarities there. I think that's really nice.
It really is. That's cool. Eric, thanks as always for the 411. Very enlightening, my friend. That was
thanks for having me on, Jerry.
Yep, my pleasure. Believe me, Slooh astronomer Eric Edelman. All right, coming up here on the show, Slooh's human spirit correspondent Helen Avery will be here to look back on the fascinating and harrowing story of Galileo's fateful discovery of Jupiter's moons and how that changed the course of human history. And later, did you know you can travel back in time and experience what it was like for Galileo to discover those moons? Paul Cox returns to show us how we can use Slooh's telescopes to recreate that moment. There is a look at Jupiter at opposition from our Canary Islands Observatory. Don't move a muscle. We'll be right back. We've been all over the world chasing solar eclipses to share with you. This time, you're coming with us. Join Slooh as we expedition to Stanley, Idaho to celebrate the transcontinental eclipse on August 21st. Sign up today at slooh.com. Space is limited. And we welcome you back. It's Jupiter at opposition, and we've been talking about the gas giant and its moons, the Galilean moons, moving across, at least some of them moving across the face of the planet, and that'll be easier to see as we move along as Jupiter gets higher and higher in the sky. Those moons are among the most famous in the solar system, the most famous in history. Their discovery changed how we think about our place in the universe. But that wasn't exactly good news when Galileo first saw what he saw. Here to tell us more about it is Slooh's human spirit correspondent, Helen Avery. Helen, welcome. What was the astronomical thinking in the world before Galileo actually made his discovery?
It was entirely different. So what happened was, up until that point, people believed that the Earth was stationary at the center of the universe and the sun revolved around it. And I say everyone, that's not entirely true. So in about there he is. So in the 3rd century, actually, Aristarchus from Samos suggested that this was not the case. Actually, the Earth revolved around the sun and not the other way around. But he was kind of laughed at by Archimedes, of all people. And in fact, people who tried to put forward this theory, or what we know now as fact, through the ages, we tend to think of it as the church who laughed him down. And I'll tell you about Galileo in a minute. But it was actually other astronomers and other scientists and philosophers who said this wasn't possible. But it did keep arising through Europe and also Muslim scholars. And in India, this idea, it's called the heliocentric model instead, where the Earth revolves around the sun. But it was never really accepted, as I say. And even when Copernicus in the 1500s really came out and said, this is what's happening, it was called the Copernican theory, that the Earth revolved around the sun. Even he kept it to a theory because he was kind of laughed at by his peers. So, and then came along Galileo, and everything kind of changed and momentum came and the whole heliocentric model was accepted. So it's like he was in the middle of time, really, where before him, it wasn't widely accepted, wasn't really accepted by anyone. A tiny fraction of people believed that the Earth revolved around the sun. Actually, most people believed that the Earth was stationary in the center of the universe. So it changed, it really changed everything.
So, yeah, the obvious question is, what did it mean for humanity? I mean, this was a seismic shift after this discovery happened.
Yeah, absolutely. So, and then Paul will talk about this later, I'm sure. But so what happened was he looked up in his telescope at Jupiter, and he saw what he thought were 4 stars. And then he went out the next night and recorded where they were, and the next, and he noticed they have moved. And so then he realized, they're not stars. They can't be stars. They must be moons. And so he saw this as evidence to back up the Copernican theory. And other people disagreed with him, sadly. But really, because he felt so strongly, and he was a very well-known figure, Galileo, and he was very well connected both in the church, although fell out of favor, and with sort of the highest ranks of society, people really took him seriously. And he also had the confidence to say, Copernicus said this was a theory, but I believe it's, I'm saying it's true because I'm looking at this and this is what's happened. So, I'm so excited Paul's going to show us that just to be able to see this tonight, and then if you look tomorrow, you'll be able to experience what Galileo experienced. That's fantastic.
Okay, so the reaction then when Galileo made the claim that Copernicus was correct.
Yes, the church did not like it because it went against the scripture, because the scripture said that the earth was the center of the universe and the sun went around it. And we have this idea that the Catholic Church was very sort of anti-science and astronomy, and that's not the case. They worked closely with astronomers to help them set their calendar, but they'd always sort of said, yes, we love your theories. Yes, it's a lovely theory. And Copernicus was seen sort of unthreatening when he was alive because it was just a theory. And then Galileo comes along and says, it's not a theory, it's fact. And all of a sudden there becomes a big problem. Now, Galileo and the Pope were good friends, but and he was sort of, this is in a nutshell, he was taken aside and told, you better zip it and talk about the cons of this model that you're proposing and how it doesn't work. And unfortunately, Galileo went out and wrote a book that said quite the opposite of why he really felt this was true, that the earth revolved around the sun. And it seems like a mockery of the Pope. And so he was pulled in for an inquisition. They threatened him with torture. There he is. And because he did know people in high places, instead of being imprisoned, he had a house arrest for the rest of his life. So I see him as like a martyr for science. And yeah, phenomenal man, phenomenal.
Oh, no question. Helen, how long did it take for everyone, for society in general, to accept these changes?
Well, thanks to Galileo and really the scandal, that's what, if you want to keep it under wraps, the church should have kept it a bit quieter. But because everyone heard about it, everyone started sort of saying, well, hang on a minute, has he got a point? If he's bold enough to go out there and say how he, what he believes in, maybe we have now the courage to say, yes, we agree with him. And so very, very quickly, it started to sort of take hold. So by the end of the 1600s, you have Newton, who's agreeing with a heliocentric model. And then in the 1700s, the church stops arguing, basically. Although it wasn't until 1820 that they actually allowed any books that talked about this heliocentric model to be published in Rome. So it did take them a little longer, but really by the 1800s, people were well into understanding that this was the way it was. Although they still thought at that stage that the sun was the only sun. So that although we revolved around the sun was the center of the universe. And also sort of step by step, we've gradually built on that to understand that, no, there are many, many solar systems and galaxies.
One more question before I let you go, Helen, and it involves the church and the scripture. For so many years, for so many centuries, they believed one thing and it was written that way. And now all of a sudden, Galileo and Copernicus come along, and science has convinced them that the opposite is true. So how did the church handle that?
Yeah, I know, right? It's sort of interesting. How did they get around it? Well, and this is why I see this event that we're watching tonight, that Galileo watched, as also not just a change from the geocentric to the heliocentric, but also a real shift between religion and science. So what happened was the church kind of came out and said, well, okay, we shouldn't take the scripture quite so literally, perhaps, and maybe it says this, but it's more of a turn of phrase. And the only way I can compare it is, you and I will both talk about the sun rising and the sun setting, and the sun doesn't rise or set. We know this. And so they sort of said, well, it's just the way it was written, and it doesn't really, we were taking it too literally back in the day, and now we're not going to take it literally, so we can get on board with this. But I feel like ever since this happened, and thanks, that's why I believe him to be like a martyr for science, that the relationship that had really fractured between religion or spirituality, really, and science has then started to shift, and slowly, like that relationship has begun to heal. Because way back in the day, astronomy and spirituality were very well connected, and then they kind of, religion came in and screwed that up. But now I feel like this was a turning point, and they're gradually sort of coming together. So it's such an important event. I'm so happy to be watching it.
Science, what a concept. Hopefully someday it'll catch on. Helen, thank you so much. We really appreciate it as
Thanks,
always.
Jerry.
All right,
Thank you.
still to come. Have you ever wanted to experience what it was like to make such a monumental discovery? In just a moment, we'll go back in time with Paul Cox to find out how you can recreate Galileo's discovery using Slooh's telescopes. So stay tuned. Give the gift of the universe. Give the gift of Slooh. A celebration of every magical moment in the night sky. For just $60, you can give the budding space explorer in your life the gift of a full year of Slooh membership. It's available now at slooh.com. And we welcome you back. It is Jupiter at Opposition here on Slooh. I'm your host, Jerry Monteur. We are looking live at the gas giant. And as we've already told you, the discovery, and as you probably already know, the discovery of the Galilean moons changed our understanding of the solar system and our place in it. But how exactly did Galileo make that discovery so many years ago, more than 400 years ago? Slooh astronomer Paul Cox is back to show us live from the Canary Islands and looking awfully warm and toasty, Paul.
Really, I wish I felt like that. I'm sitting in our new Dome 3. I'm looking up at a lovely waxing gibbous moon, which some of the Slooh members won't particularly like because moonlight kind of makes the images quite noisy. But for planetary imaging, It doesn't make any difference whatsoever. And I'm looking right down the tube of the telescope that's actually producing this live video view. And there I can see it in the distance. It's so obviously, you know, the brightest thing other than the moon in the sky. And anybody can witness this. About half an hour to an hour, as soon as it gets dark, basically, after the sun has set, wherever they are, and they'll see this rising in the east. And it's a spectacular sight, even if you've only got a pair of binoculars, Jerry.
Okay, Paul, we've been teasing this Galileo thing all show long. So how does this work? How can anybody out there channel their inner Galileo?
Well, I don't know. I mean, no one told me I was going to talk about this tonight, Jerry. No, I jest. I jest. It's actually one of my favorite stories, actually. And, you know, Helen's already talked a little bit. I'm just going to I've just changed the exposure time of this live video view, which will come up in a sec, because I do want to just point out the moons in this particular shot. So Helen has already kind of given the game away a little bit. You know, it was on the, what was it? It's the 7th of January, 1610, right there. So I've overexposed Jupiter, and there we can see the little dot at the 1 o'clock position on Jupiter.
Wow.
That's the moon Ganymede, and it's just popped out from transiting in front of the face of the planet. And the other two dots on the right-hand side, they were the moons Europa and Callisto. And in the wide field view that we've got tonight, we can also see a little dot to the left of Jupiter, and that's the moon Io. Now, the views that we were getting, Jerry, at the beginning of the show, when Ganymede was in front of Jupiter, we could only see 3 of the moons. We could see Io, Europa, Callisto. That is the view that Galileo Galilei had on the 7th of January, 1610. He actually only saw 3 of the moons that first night when he looked. And as Helen said, you know, he thought they were, you know, he thought it was a little bit strange that these things were laid out in such a straight line around Jupiter, but he thought they were background stars until the following night he looks again through his telescope. And actually, if people want an idea of what Galileo's view was actually like, it's incredibly similar to our T2 wide field view that we've got tonight. He would have seen it as, even through his telescope, actually, he could have told that Jupiter wasn't a star because you could see that it was a disk. So this is the kind of view that he was getting. And that's what he saw. He saw these 3 little moons on either side. The following night, though, 4th one appears, and the 3 that he saw the previous night have moved. Well, I mean, you can imagine a brain like Galileo. I mean, the world must have spun literally for him. And as Helen's been talking about, you know, it really spun the world on its head, getting us away from this Earth-centered model of the universe. And, you know, it was really the first time that anyone had observed something which could really prove that heliocentric model. You know, so Copernicus had talked about it, you know, in 1514, but this through observation. And don't forget, that's what science is about. It's about observation. And this is what he did. He observed Jupiter over successive nights. And on a little piece of paper, this is actually his real manuscript, he drew the positions of the moons every single night. And if people look in the clubhouse, I've actually, they can look at these things in slightly more detail. And there's a transcript that I made of his manuscript where he describes what he's viewing every single night. There it is. Wow, the studio on fire tonight. And this is it. You know, it's this little sketch pad, and he's sketching it out. And he's saying, you know, the spacing of the 3 to the west was no greater than the diameter of Jupiter. And at the end of all of this, he actually challenged all astronomers. He said, I summon all astronomers to apply themselves to examine and determine their periodic times, because he didn't actually manage to do that. But if members want to replicate what he did, we've got this plain piece of paper, and all they've got to do is print it out. If you go into the clubhouse, it's in there. It's all in an activity, actually. So this is all described in a little video. in the clubhouse as well. But they can plot Jupiter every single night. There it is. And they can plot the positions of the moons. You need a minimum of 9 nights to do this. It doesn't matter if you miss a night. If you've got clouds one night, it doesn't matter, because what you get at the end of this is something very, very similar to what Galileo had that we've just seen. This plotting of the moon. And very quickly, he was able to see that these were 4 objects which were orbiting Jupiter. And what he then did was, if you look at this particular thing, you can kind of see it. You could join up those moons from night to night, and it forms these huge S-curves. And this is what they land up like. So if you do this exercise, this is what happens. And there you've got it. 4 very distinct bodies orbiting Jupiter. And when you plot them out like this, you can even determine their orbital periods. Io, the moon closest to Jupiter, whizzes round Jupiter in 1.7, 1.8 days. Europa, twice that. And Ganymede, twice that. So Ganymede goes around in something like 7 days, a little over 7 days. Callisto isn't kind of locked into those ratios. Callisto takes 16, 17 days. So that's what you get. And it is so easy, because even if you don't use the Slooh telescopes to do this, that's the view that you would get through a pair of binoculars. So from your own backyard, you're getting exactly the same view through a cheap pair of binoculars as Galileo had through his telescope. And you can go through exactly that discovery process that he did. And just to imagine, I mean, what you were talking to Helen about, this was a meteoric discovery. Imagine doing that back then. I mean, I think Helen was quite kind to the Catholic Church, but I usually have this is usually I get on my soapbox now and have a good old Catholic Church bashing exercise and church dogma and all that, but save me from it, Jerry. What else do you want to know about this wonderful exercise?
My first comment after all that is what you need, Paul, now is a long white beard and a nice robe, and you will be Galileo.
Thank you very much.
It sounds to me, Paul, like Jupiter might be your favorite planet.
It is. I mean, absolutely, without any question. And it's because there is always something to see. I mean, even tonight, you know, we've already seen Ganymede, largest moon in the solar system, transit in front of the face of the planet and then emerge. A little bit later, just after midnight, in fact, it's 40 minutes past midnight. So actually, for people on the east coast of the USA, this is going to be around dusk at that time, and the Great Red Spot is going to spin into view. It's going to appear on the left-hand side of Jupiter. At a couple of hours, 3 hours later, you'll see the Great Red Spot plumb dead center on the face of Jupiter, lower down than center. Then we've got Europa is going to be eclipsed by Jupiter later on. Then Europa gets occulted by Jupiter. Then its eclipse ends. You know, all of this stuff is all happening in one night. And I think Eric said it, Jupiter spins on its axis. A Jovian day is 9 hours, 56 minutes. That means that tonight, in one night, we see every single part, every single face of Jupiter. And there's something more than just the minute-to-minute changes, Jerry, that I love about Jupiter. I've been a Slooh member since 2003, 2004. I've been tracking Jupiter over all that time, and we've watched the Great Red Spot change color, start getting smaller and smaller. We saw 2 other spots, right? These huge storms join together and actually become Great Red Spot Junior. We've seen changes, huge changes in the equatorial belts, the colors of the atmosphere of Jupiter. It is like its own little solar system. And that is what Galileo saw that night. For the first time, he saw bodies orbiting Jupiter in exactly the same way that they thought our solar system worked, with everything else orbiting around the Earth. You know, so it's all kind of joined up in the end.
another thing that's fascinating about Jupiter, as far as I'm concerned, is the size. It's almost indescribably big. Ganymede is bigger than planet Earth. That's a moon that's bigger than our planet. And there's the red spot. The red spot, even though it's shrunk, is bigger than planet Earth.
Yeah, Ganymede is actually bigger than our moon, and it's bigger than the planet Mercury, but it's not larger than Earth.
I
It is the
misunderstood.
largest. It is the largest moon, but it's larger than Mercury. So, yeah, it's like we said at the top of the show. If Ganymede, that moon that we saw transit in front of the planet tonight, if it was orbiting the sun, it would be considered a planet, and it wouldn't even be the smallest planet. But yeah, you're right. Jupiter contains, it's something like 2.5 times the mass of all of the other planets and asteroids put together in the solar system. It truly lives up to its name when we call it a gas giant.
Paul, it's been fascinating as always. Thank you so much. Stay warm if possible.
Thank you very much. I'm just going to get this planet centered up again, because we're going to be carrying on this feed until at least midnight, so at least another 3 or 4 hours.
All right. Appreciate it, my friend. Take care. And that about wraps it up for us here at Slooh for now. Thanks so much for joining us to explore the opposition of Jupiter. The night, as Paul mentioned, is far from over, though. After the show, stick around. We'll watch the gas giant throughout its brightest night and experience nearly an entire day on the planet through our live telescopic feeds. If you enjoyed tonight's event, we do this all the time here at Slooh. We offer live views of space through our telescopes in the Canary Islands and Chile, and regular live shows to our members. It's never been a better time to be a member of our community either, as we prepare to launch a brand new Slooh full of new features and new ways for you to interact with each other and explore the universe. We look forward to seeing you again for our next show that takes place on April 21st, as we sit back and experience the Lyrids meteor shower. We'll have live meteor cams from around the world searching for the skies, and the celestial fireworks show that is going to happen all night long. So join us at 8 p.m. Eastern on April 21st for that stunning event. And the following day, we'll be celebrating Earth itself, looking down on our planet as we enjoy an Earth Day event. We'll be speaking with real-life astronauts and members of the Slooh community to find out what we would miss most about our planet if we took to the stars. Now, you can let us know what you would miss by sending us a short 10 to 15-second video expressing your thoughts about the planet. We'll be sharing our favorites during the live show on the 22nd. You can find more about that, more info on our Facebook page. Well, thanks as always to our guests, including Slooh astronomers Eric Edelman and Paul Cox, and of course our human spirit correspondent, Helen Avery. And a very special thanks to all of you for joining us. So thanks for stopping by. I'm Jerry Monter. You're watching Slooh, Space for Everyone.
Hi, I'm Helen. I'm the Human Spirit Editor here at Slooh. And this Earth Day, we're inviting you and people all around the world to send us videos saying what you would miss about our planet were you to go into space. We'll be putting together the best of these videos and showing them during a live show at 9 a.m. Eastern on April the 22nd. So if you or your friends or family want to join us and send in a video, it's very simple. Just take your smartphone, turn it horizontally, and tell us in whatever your native language is what you would miss about Earth were you to go into space. Then you're going to email it to me, helen@slooh.com, with your name and city in the subject line, and then join us on Earth Day to see if your video made the cut. you.